Welcome to all. In the previous video of differential geometry, we are looking into examples on finding velocity vector. Now we will see one example on reparameterization of curve. The question is like, find the coordinate functions of the curve beta is equal to alpha of h, where alpha is a curve given by alpha of t is equal to 2 cos square t sin 2t and sin t, with range of t as t is lying between open interval 0 to pi by 2, and h is a function on the interval j such that 0 is less than s is less than 1, and h is given by h of s is equal to sine inverse of s. So first what they have asked is, find the coordinate functions of the curve beta. So beta, we can see beta is a function of alpha, which in terms is function of h. So by seeing that only we can see it involves with composition of functions. We have studied reparameterization is indebted with the concept of reparameterization, like composition is involved in reparameterizing a curve. So we can see alpha given by alpha of t is equal to 2 cos square t sin 2t sin t, and t range is mentioned, therefore alpha is a function from the open interval 0 to pi by 2 to e cube, and j is given as 0 less than s less than 1. So j is a open interval 0 1, therefore h is a function from j to I. So here I means 0 to pi by 2, therefore h from 0 1 to 0 to pi by 2 is a function which is given by h of s is equal to sine inverse h. So now we can see we have alpha and j. So by composition of functions we will have h of alpha, which is from 0 1 to e3. So this composition function is nothing but our beta. So we can observe the concept of reparameterization involves composition of functions. We just follow the procedure as we have seen in the reparameterization concept. Now we have beta of s as alpha of h of s. So just replacing the coordinates of alpha with h of s. So replacing, instead of t we are writing h of s. This is equal to 2 cos square, instead of t I am putting h of s sin 2 h of s sin h of s. So since h of s is sin inverse of s, just we will put h of s as sin inverse s. 2 cos square sin inverse of s sin 2 sin inverse s sin of sin inverse s. So we can see this can be simplified further. So we will see how it is simplified. Now consider one term. First we will consider cos square sin inverse s. Since we know that cos square theta is equal to 1 minus sin square theta, therefore we can write cos square of sin inverse s is equal to 1 minus sin square of sin inverse s. But sin of sin inverse s is equal to s. So we can write it as 1 minus s square. So this is cos square of sin inverse s. Now we have to write for the second coordinate sin 2 of sin inverse s. We know that sin 2 theta is equal to 2 sin theta cos theta. So therefore sin of 2 sin inverse s can be rewritten as 2 into sin of sin inverse s into cos of sin inverse s. So we can write from the cos square is equal to 1 minus sin square, we can write cos is equal to cos theta is equal to root of 1 minus sin square. So just replace cos of this with in terms of sin, sin of sin inverse s into root of 1 minus sin square of sin inverse s. So this is sin of sin inverse s is equal to s, here also sin of sin inverse is s, this is s square 1 minus s square, and the last term is sin of sin inverse s, so it is simply s. Therefore, the curve beta can be rewritten as beta of s is equal to 2 into, so instead of cos square of sin inverse s, we can write 1 minus s square. For second coordinate, we can write 2 into s into root of 1 minus s square, and last term is s. So this is about how to find the coordinates of the reparametrized curve beta. So it involves finding composition of two functions. One is curve in E3, another one is a differentiable function. Alpha is a differentiable curve and h is a alpha is a curve in E3 and h is a differentiable function. By composing both of them, we will arrive at the reparametrized curve. So this is how the reparametrization of the given curve with the help of a differential function follows. So this is about how to reparameterize a curve. We will find one more example in the next video. Till then, keep watching. Thank you.